All right, so expectation. What is it all about? Expectation generally means what do you expect to happen, right? And that's what we're talking about here. But the expectation actually is calculated. So it's not just how you feel about it. It's actually a calculation that we can do. So consider this problem. A die is rolled 120 times. How many times would you expect it to be a 6? So if you think about if it's a 6-sided die, there's 6 possibilities. The probability of getting a 6 is 1/6, right? So we would expect, if we roll it 120 times, if it follows the sort of theoretical probability, that we would get 1/6 of 120. So we get 20. All right? So that's the concept of expectation. Not a difficult concept, but it's just the number of members in the sample multiplied by the probability of each of those occurring. And it essentially gives us what our result is going to be most of the time, or on average. Okay? So it's kind of like the average. So here's an example. A charity fundraiser gets a license to run the following gambling game. So if you roll a die, if you get a 6, you win $10. If you get a 4 or 5, you win $4. And if you get a 1, 2, or 3, you get $1. And it says that you have to pay $4 to play. So here are the questions. What are your chances of playing one game and winning $10? Well, there's only one way to win $10 is to roll a 6. And there's only one way to roll a 6. So the probability is 1 out of 6. To get $4, there's actually 2 possibilities out of 6. So that comes down to 1/3, right? And then for $1, there's 3 possibilities out of 6, which reduces down to 1/2. So our probabilities are 1/6, 1/3, 1/2. Now, it says your expected return for throwing a 6 is 1/6 of $10. What's your expected return for throwing a 4 or 5? So it's 1/3 multiplied by 4. So it's 4/3 or $1.33. And then a 1, 2, or 3, we have a half possibility of doing that, and we're multiplying it by 1, so it's 50 cents, right? And then a 1, 2, 3, 4, 5, or 6, we simply just add those 3 together. So we have 1/6 times 10 plus 1/3 times 4 plus 1/2 times 1. So 10 over 6 reduces, right? If we divide them both by 2 to 5/3 plus 4/3, and then we're adding a half. Oops. So 4/3 of, that's 5/3 of 4/3 gives me 9/3, which is 3. So I end up with $3.50. So my expected return is $3.50. I paid $4 to play, so it makes sense because the game is set up so they're going to make money, right? It's a fundraiser, so they're not going to set it up so that you lose. Or I mean, like the organizers aren't going to set it up so they lose, so you are going to lose, and that's how most casino games work. All right, at the result of 100 games, we just take our expected return in one game, which is $3.50. We multiply it by $100, and we expect to make $350. Now, what did we pay? Well, to play, we paid $400, so we're going to lose $50 if we do it. The only time that, and this is important to understand, that if it's set up so that whatever your expected value is, that's what you pay to play. In other words, your break even is 0. So if you pay and you average what you're supposed to average, it's exactly the same. That is considered to be a fair game. And there will be questions that ask you, if we're playing a fair game, what is this or what is that? And that's what it means. So that's expectation. All right, that's how it works. In other words, to put it in a formula, it's just the sum of the probabilities multiplied by the value of those probabilities. Okay? So you're just taking the probability of each event occurring multiplied by the actual event. So in our case, it was $10, $4, or $1. Right? So here's another example, and we'll just quickly go through this. I have it written out so you don't have to watch me write everything out, but it says a person plays a game with a pair of coins. If a double head is spun, $10 is won. If a head and tail appear, $3 is won. And if a double tail appears, $5 is lost. So it says how much would a person expect to win playing this game once? So we have $10 multiplied by the probability you get 2 heads, which we talked about in a couple questions earlier in a different video, I guess, but it's 1/4, plus $3 if you get a head or a tail. That's multiplied by 1/2. That's probably to get a head or a tail. And then minus, because you're losing $5, times a quarter. So you end up with, just adding those together, you end up with $2.75. So that's what you expect to win. So it says if the organizer of the game is allowed to make an average of $1 per game, how much should be charged? So if you average 2.75 by playing, the organizer is going to charge you $3.75 in order to ensure that they're making $1 a game. And this expectation, this idea of expectation becomes important because when you're setting up things like this, it actually has a practical implication. If you can figure out what your expected return is, you can then figure out how much you should charge to make money. And obviously you want to try to make as much money as you can. All right, now, we get into expectation kind of becomes the mean, and the standard deviation is the same kind of concept. The mean is just the frequency multiplied by the x value divided by the frequency. Okay, so it's very similar to the expectation, because if you add up all the frequencies, it generally adds up in a probability distribution. It adds up to 1. Now this is for any sort of frequency diagram. We talked about this already, but if it's a probability thing, the probabilities add up to 1. So you end up just with the expectation. If that makes sense. Hopefully it does. So if you look at the count, it says we have 10 counters. 1, 2, or 1's written. 1 has 1 written on it. There we go. 4 has 2, and so on. Then you can actually come up. You can read the thing if you want to, this slide. But basically, you come up with the possible values are 1, 2, 3, or 4. There's 1 that has 1 written on it. There's 4 that have 2 written on it. 3 for 3 and 2 for 4. And then you can come up with your probability. So you can use your frequencies to determine your probabilities. All right, and then you can figure out the mean and the standard deviation. So what ends up happening is your mean becomes your mean is your expectation if you're doing a probability distribution, because what you're dividing by is always 1 in the sense that it has become the denominator in your probabilities. And the standard deviation, that's your formula for standard deviation. Okay, and those two are really ones that are important. Particularly this one. This is the one that you are going to have on your formula booklet or in your formula booklet that allows you to calculate expectation. So we're going to practice more with that. You don't need to know all this stuff, but this is kind of where you need to end up. That these are the formulas for the population mean and the population standard deviation of a discrete random variable with probabilities. So we'll leave it there. That's expectation. So we've talked about probability distributions in general. We've talked about a specific discrete random variable probability distribution. Now we've talked about expectation. The next thing we're going to talk about is the binomial distribution. So there's a couple of examples. We'll do those in class, but then we'll talk specifically about the binomial distribution in the next video. So we're going to stop there. These are the 3 videos you need to watch for tomorrow, and we'll talk about binomial distributions after that.